Hello there, welcome to this tutorial. It's an statistics grouped data, and we are taking you on mean deviation, variance, and standard deviation of grouped data. So let's go. Our problem: the weight in kilograms recorded by final year students are as follow. Calculate the mean deviation, variance, and standard deviation. So to start with, we are going for the mean. Our usual formula for mean: summation of fx over summation of f. And from grouped data, the x is not given, so we are going to create two additional columns for x and fx. So we have two additional column, x and fx. So the x is the mid value of the class interval. So for each of the class intervals, we shall calculate the mid value to represent the x. So we start with the first class interval. 54 plus 57 divided by 2 gives 55.5. 58 plus 61 divided by 2 gives 59.5. 62 plus 65 divided by 2 gives 53.5. 66 plus 69 divided by 2 gives 67.5. 70 plus 73 divided by 2 gives 71.5. 74 plus 77 divided by 2 gives 75.5. 78 plus 81 divided by 2 gives 79.5. 82 plus 85 divided by 2 gives 83.5. So we have gotten the mid values, which represent the x column. So we go ahead to calculate fx. Fx means frequency multiplied by the mid value, which is x. So 5 times 55.5 gives 277.5. 7 times 59.5 gives 416.5. 10 times 63.5 gives 635. 12 times 67.5 gives 810, and 6 times 71.5 gives 429, and 5 times 75.5 gives 377.5. 4 times 79.5 gives 318, and finally 1 times 83.5 gives 83.5. So we shall sum up the frequency and the product of the frequency and x. So we shall sum up the two columns. So summing up these columns, we have a 50 here. Summing up this, we have a 3347. Now we substitute this summation of fx and summation of f in the mean formula. So that's going to give us 3,347 over 50, and that will give us 66.94 kilograms. So the mean of the distribution here is 66.94 kg. Now we go to mean deviation. For our mean deviation, the formula is summation of absolute value of x minus x bar divided by summation of f. So what we do is we get the x minus x bar. X bar means the mean of the distribution we just calculated. So we are going to get x minus x bar for each class interval multiplied by f, sum them up. We're interested in the positive difference. So this x bar means the mean we just calculated, which is 66.94. So we create two additional columns, the columns for absolute value of x minus x bar and the product of that with frequency. So we have additional column. The first one is x minus x bar, then f times x minus x bar. Now we come to x here. This is 55.5 minus 66.94. We have already calculated our mean to be 66.94. So, and we are looking for the positive difference. So we have a 11.44. 59.5 minus 66.94. We have a 7.44. 63.5 minus 66.94 gives 3.44. 67.5 minus 66.94 gives 0.56. 71.5 minus 66.94 gives 4.56. 75.5 minus 66.94 gives 8.56. 79.5 minus 66.94 gives 12.56. And finally 83.5 minus 66.94 gives 16.56. So now to get this column, we multiply the frequency by x minus x bar. Now we now have 5 times 11.44, that gives 57.20. 7 times 7.44 gives 52.08. 10 times 3.44 gives 34.40. 12 times 0.56 gives 6.72. 6 times 4.56 gives 27.36. 5 times 8.56 gives 42.80. 4 times 12.56 gives 50.24. And finally 1 times 16.56 gives 16.56. Again, we shall add this column to give us the summation of f into x minus x bar. So summing up these values, we have 287.36. So we now go ahead to substitute the values we have obtained into the mean deviation formula. So that's going to give us this 287.36 divided by 50, and we have our result as 5.7472, which represents the mean deviation of this distribution. Now we go for variance. Going for variance, this is the formula for variance: summation of f x minus x bar absolute squared. What we do is we find x minus x bar, square it, multiply by the frequency. So we already have this x minus x bar here, we have this here. We are going to square this and multiply by 5. Square this, multiply by 7, square this, multiply by 10, and so on for the column. So we have the column f into x minus x bar squared. So now we go ahead for that. Now we proceed. So we squared 11.44. So the result multiplied by 5, it gives 654.368. Again, 7.44 squared multiplied by 7 gives 387.4752. 3.44 squared then multiply by 10 gives 118.336. 4.56 squared multiplied by 12 gives 3.7632. 4.56 squared multiplied by 6 gives 124.7616. 8.56 squared multiplied by 5 gives 366.368. 12.56 squared multiplied by 4 gives 631.0144. 16.56 squared multiplied by 1 will give 274.2336. So we are done with this column. What we do now is to sum up the values to give us the summation. So summing it up, we have 2560.32. We now substitute this into this variance formula to get the variance of the distribution. So we have it as 2560.32 over 50, and from there we have our answer as 51.2064. This represents the variance of this distribution. Then we now go ahead to calculate the standard deviation. The standard deviation is immediately from the variance. So standard deviation here is the square root of the variance. Square root of variance. So finding the square root of variance, we are going to find the square root of 51.2064, which gives 7.1559. So we have done justice to this problem by calculating the mean deviation, variance, and standard deviation of this distribution. That is the end of the solution to this problem. Remember to subscribe to our YouTube channel at Oninabo Resources. Thank you for watching this video. Goodbye.